Okay, we are recording officially. Welcome to First Flights with Eagle, Episode 3. So far in Episodes 1 and 2, we have covered making a schematic, making a board, and in today's episode, our goal is going to be generating the manufacturing data. So that entails a bill of materials, it entails Gerber files. In some cases, it entails something called a pick-and-place file. It goes by a few other names, such as Centroid or XYRS file. So please let me know if you guys are able to hear me. At this moment in time, just send it through the chat. Please let me know if you guys can hear me. Okay? Okay, good. Looks like most of you guys can hear me. So I'm going to go ahead and get started. I'm going to share my screen. Cool. Okay, awesome. So right now you guys should be able to see my control panel. Let me know if you can. Just want to make sure. If you guys can see my screen, let me know. Okay, good. Excellent. So let's go ahead and get started then. We're going to be using the same files we used last time. At any point you guys have questions, feel free to send them through the chat window. So we're going to go to Projects, Eagle. We're going to go into First Flight, which is the files we have been working with as of late. Okay, and here we have our schematic and we have our board. Okay? So one of the first things we're going to do is generate a bill of materials. Okay? So how can we do that? In Eagle, there's several ways to do it, some easier than others. So I'm going to start by showing you guys the method that I consider most flexible and easiest, and then we'll work with other options as well. So generating bill of materials in Eagle generally will entail using a UOP. Okay, if you've never run a UOP before, UOP simply stands for User Language Program. Basically, these are C-like scripts that you can run in Eagle to automate tasks or add functionality to it. Here at CADSoft, we actually get a lot of stuff done using them, so it pays to be familiar with them. If you would like to find out more information about the UOPs that come with Eagle, just go to the control panel, expand the User Language Programs tree, and you'll see all of the UOPs that come with Eagle. And if you click on one, you can see its description. Okay, sometimes you'll get information about its command line parameters and such. So definitely any information you want about a UOP, this is the best place to find it. Within Eagle, there's also some on our website. Here's one of the more sophisticated documentations, the one for the Find UOP. We have many more on our website you can download at www.cadsoft.usa.com. Downloads User Language Programs. So for now, let's go, like I said, with the easiest method of bill of materials generation, which I consider the bill of materials UOP. So we click on the UOP icon, brings up this listing, which is all the UOPs that come with Eagle. Last I checked, it was about 300. 300 libraries that come with Eagle. UOP is about 110 that come with Eagle. And this is the BOM.UOP, the bill of materials UOP. And this is the simplest one. This is the vanilla that comes with Eagle. All the other derivatives you will ever find of the bill of materials UOP usually use this one as a base. So just double click it, and here we have our bill of material UOP. So you can see it lists every component in our design. Now we can, if you notice, it's each one independently. However, if I sort it by values, then that can make it a little bit easier. See, we have 4.1 microfarad capacitors. Tells you what parts use that. If you notice here, we have this attribute, manufacturer's part number. Okay, and we have Farnell and Newark numbers that we can add. Okay. This list can be exported in several formats. If you select text, it's going to export as a tab delimited text file. If you select CSV, it's going to export it as a character separated value list, which uses semicolons as a separator. It doesn't use commas by default. Most of you guys, if you're in the States, you'll be used to commas. However, Excel and LibreOffice Calc can use any arbitrary delimiter, so it's not a big deal. And finally, you can also export it as an HTML file. Okay? As you can see, it's very easy to get the data we need. Now, some of you may be wondering, well, how do you get in the manufacturer's information? Because that would be handy to have it all populated. And then I can export it as a CSV and open it in Calc or Excel and just have it ready. So the way we do this is using the attribute command. So if we go over here, you guys will see there's an attribute command. I can click, for example, on this part. Here we have one attribute. Okay. We can obviously create others. They're very simple. So let's say manufacturer. Its value is going to be microchip. This is a microchip pick. Okay. Pretty simple. We can create as many as we want. It's not difficult at all. So once you've created the ones you want to create, we can do this for all the parts. Okay, so you'll see that some of the other parts do have these in them. Find one, another one that has it. If we run that bill of materials UOP again, you're going to see that now, for the pick, we have here under MF, we have the MPN. Okay? You can see it's pretty simple to add them in. Here for the switch, we have all these other attributes. So as you can see, the attributes are user definable. They're very easy to do. You can also add attributes to the whole schematic and then fill in the respective values using the attrib add UOP that's up on our website. Another option, which maybe for some of you is simpler, is to use Design Link. Okay? If you just click on it by itself, you'll see that you'll get the option to run a general search or a schematic search. If you do general, it just lets you look up for any particular part, its availability and its and its cost and such. Okay, very simple. However, if we run through the schematic, it actually is going to do something interesting. It's basically going to search for each individual part, and then we can select from Newark's part numbers which one this part's going to be. Okay? So I'm going to ask you guys to bear with me for 1 second. We'll be right back, having a little technical issue here, okay? Give me 1 moment. I'm going to pause the recording. Sorry, guys. Bear with me 1 moment. What about the technical difficulty there? Let me know if you guys can see my screen. Okay, just confirm if you guys can see it. I think everything should be all right now, but just confirm that you can see it. Okay, awesome. Excellent. Okay, good. Now let's go ahead and carry on with what we were analyzing here. Lesson, okay. All right, so Julian put in a question of if he could obtain downloads of lessons 1 and 2. Yes, he can, and actually lessons 1 and 2 are on YouTube. This will eventually be on YouTube as well. Okay, so we started to play some of our videos on YouTube. This series, at least the first main episodes, will be available on YouTube. Okay, so definitely just look up the main CADSoft channel. I believe in German it's Kanal von CADSoft Computer, something like that, and you'll be able to get lessons 1 and 2. Okay. So here, as you guys can see, I have a capacitor, 0.1 microfarads. Okay. When it does a search, it's actually going just off the value, which isn't enough information. However, we can add to that. We can put in microfarad, 0805 capacitor, and we can manually search for it. Okay, so let's say this capacitor here was actually good. Well, it's not good enough because there's none available. Let's go with this one. Okay, this one is available. 7R, perfect. We'll go with this one. We can just select it, and now it automatically becomes part of our bill of materials. And we can continue to do this. So again, we have microfarad, 0805 capacitor, search, this, X7R, perfect. 16 volts, more than enough headroom. This is just a little 3.3 volt circuit. Now, obviously the pin header names aren't too helpful in this case. So we may just want to look up the 0.1 inch male pin header. Let's search for that. We can try looking through here. Contact, 0.1 pitch. Not getting any pictures on these, so it would be a hard determination. Obviously, beforehand, you would do the research and just look up the specific parts. Okay, but this basically gives you the idea of how you could form it. And if we then continue, we'll eventually get to a point where we have a completely populated bill of materials, as you guys can see here. Okay, so all of this would be filled in, and we could export it as a CSV file. Okay, or as whatever file format you wish. You can also, from here, directly buy it. So this is the other option, or one of the other more sophisticated options. But usually, just the bill of materials UOP that comes with Eagle is enough. Any questions on the bill of materials stuff so far? Any questions? What if you use Farnell? It will pick up. Design Link goes into Farnell as well. Okay, so if you use Farnell, Design Link does automatically pick that up. Okay. Recording, awesome. So let's go on to the next thing we can produce. Okay, the rest of the manufacturing data all has to do with the board. So we're here in the board editor. Now normally when we're talking about manufacturing data for a board, usually we're talking about generating the Gerbers. However, there are occasions where other files may be requested of you. So we want to go ahead and take advantage of this time to kind of cover the various things they could ask you for. Okay? If you're going to have the manufacturer assemble the board, in other words, you're going to have them solder the components instead of you doing it at home, 9 times out of 10 they are going to ask you for a pick-and-place file. It goes by various names. You might see XYRS. You may see as well Centroid file. They all represent the same thing. It's basically a file that contains all of the component locations as well as their rotations on the board and what side they're on. So there's lots of UOPs to do this. Sometimes the manufacturer will provide you the UOP for it. If they do not, Eagle comes with several default UOPs which you can use to generate that file. So I'm going to show you the one that I always use, and it has always worked out fine. So we go again to the UOP icon. I'm sure you guys are starting to see a pattern. We're going to go to Mount. Search for it. Mount. Okay, and you'll see we have several Mount UOPs. The one we want is Mount SMD. Okay, just double click it. And you're going to say what folder it's going to be in, where you want to save it. We're going to say save. And we're going to say save again. Basically, this UOP, all it does is it generates a pick-and-place file for the top of the board, and then a pick-and-place file for the bottom of the board. And so you guys have an idea of what these files look like. They're actually very simple files. They're purely text files. So we go over here to Projects, and you'll see that now we have an MNB and an MNT file. MNT, mount top, MNB, mount bottom. So if I open up the bottom, which is the one that's going to have less data, you guys will see it's pretty simple. We have the reference designator, X location, Y location, its rotation, value, and package type. Okay, pretty simple. Because it's an MMB file, they know this is for the bottom. MNT works pretty much the same way. Okay? So very simple files, but usually this is enough for the manufacturer to get the data they need in order to be able to assemble your board. Okay? Another commonly requested file is a drill legend file. Okay? Basically, it's just usually either a Gerber or a PDF showing all of the drill locations on the board, showing where all the drills are, all the holes, as well as their size and whether they're plated through or not. Okay? Eagle can generate this automatically again using a UOP. So UOP called Drill Legend Stack. Okay? And we'll see them here. This one right here. Okay, if you just run that, you'll get this setup. Usually you don't have to tamper with it at all. It's ready to go. You just say OK. And what you guys are going to see is after a few seconds, it's going to draw this table. Okay. This table tells us how many types of drills there are. We have 2 different types of drills. What the drill size is in mils, in millimeters, and how many we have of each, and whether they're plated through or not. Because all of our drills are plated through, they both say yes. We also see the symbol that's assigned to them, and if we zoom in, we'll be able to see the symbol. Okay? So normally, if we wanted to export this, what we would do is we would turn off all the layers, okay, and leave dimension. We would leave the drill legend layers, which are these here. And is there anything else we would leave? That's about it. We can leave T-place, if anything, just to give a little bit of noise. So we say apply. Okay. We can say OK to that. Okay, and basically what this does is it tells the board house just visually at a glance where all the holes are and what their sizes are. Sometimes this will be asked of you as well. Okay. And again, you can just file, go print and print it as a PDF. Very simply. It'll be what you see is what you get. You can scale it. That way they can see it easier. Something like that. Hit OK, and it'll create it automatically in the same directory. Go over here. Where is it? LSCR. There it is. PDF. Okay? So pretty simple. Okay, it can also be put in the Gerber, and it can be put in an image. A lot of times, it's going to be very dependent on the board house. Every board house kind of wants it in a different way. So they'll let you know how they want this information presented to you. But this is how you can create the drill legend table. Okay, let's put our layers back the way they were. And I'm going to take advantage now to kind of show you a neat little trick. If you right-click on the layer settings command, you'll have the option last. And it'll basically put it back the way it was before. Okay? There's several other commands that have that option with the right-click. You have the SCR command. It shows you all the recently run scripts. Same thing with the UOP. It'll show you all the recently run UOPs. Okay? I'm seeing that I have some questions. Let me check what's going on. Cool. So let me go ahead and zoom this out. So we've covered a drill table. We've covered bill of materials. We've covered centroid file. Now we're going to worry about the most important set of files, which are the Gerbers. Okay? Now, I'm going to show you the easiest way to generate Gerbers. using the CAM processor, but I'm also going to hint at how you can modify this for more complex boards, okay? So we're going to go ahead and click on the CAM processor icon, which is this one right here. Okay, now in this state, in this default state here, the CAM processor is basically undefined. It's not set up. So don't ever try to process this because you're not going to get anything useful out of this. The best way to use the CAM processor is to use the default CAM jobs as a starting point, or if they fulfill the need completely, then you can just go with that. Okay, but if not, they're a good starting point and you can expand them for whatever requirements your board has. So to use a CAM job, it's very simple. We're going to go File, Open, Job. And these are the default CAM jobs that come with Eagle, okay? Gerb274x.cam is what you'll normally use. It's set up for 2-layer boards that only have components on top, okay? Let me repeat. 2-layer boards that only have components on top, okay? Now, if we remember this board, even though it's 2 layers only, does have components on the bottom. So that I can't, right off the bat, use Gerb274x.cam. Okay? So what can we do? Well, one option is this CAM job. The 4-layer CAM job is obviously for a 4-layer board that has components mounted on both top and bottom. 4-layer board, components on top and bottom. So one option, and the one I'll usually recommend, is to use Gerb274x/4-layer and just ignore the output of the 2 inner layers since it's going to be empty anyway. So that's what we're going to do in this example. I'm going to hit Process Job. We have to save the board. Say yes, and that's it. They were created. And the way we can know is if we go back to the control panel and refresh it, you'll see that we have all these extra files. Okay? Sorry. Here, these. Okay? Each of these files is a Gerber file. Okay? And you may be wondering, well, what do each of these extensions mean? Okay? Easy way to find out, if you go to CAM Jobs and select Gerb274x4-layer, here's the full description. Okay? Component side, which is top. Inner layer 2, inner layer 15, solder side, .sol, associated component side, PLC, PLS, SDC. So you can figure out the full description of what any of these CAM jobs generate just by looking here. Okay? So that helps you, kind of sift through what these extensions are. So as I had mentioned before, I don't need the 2 inner layers, so I'm going to delete these files. I right-click, select the delete. Right-click, select the delete. Okay. Now you'll notice that there's files that were generated that we're not familiar with, specifically this .gpi. This .gpi is a summary file of the CAM processor. It has no design data in it. You don't want to send it to the manufacturer because it's just going to confuse the living daylights out of them. So my recommendation is go ahead and delete it. It really is only useful if, for example, the CAM processor showed some error or something. There would be more information there. But in our case, it ran flawlessly, so I wouldn't worry about it. Okay? So that's basically how you can generate the Gerbers. Now, as you guys notice, by default, it put everything into the same directory where our project is at, and that's thanks to this %n variable. %n basically is a variable that contains the current path of the project and the project name. Okay, you have full control over this. So you could, for example, adapt your CAM jobs to write into a specific directory and not just the root of the project. That way it doesn't clutter up the project directory like we can see here, that we have all these files here. You can maybe create a Gerber folder in here and then have the CAM processor point to it and put the files in there. For more information on how that would work, you can go into the Eagle manual. Go into Chapter 9. Okay, if you go here, you'll find our description of how all of these work. Okay, and you'll see a description of the various placeholders. These are the drill symbols we used before for the drill legend. You hear the extensions, how the placeholder works. All of that is defined here in Chapter 9. So if you guys want to get a bit more fancy with the CAM processor, you can do that here. The final type of file we're going to generate is the drill file. Okay, and it's actually pretty much through the CAM processor, it works the same way. We go File, Open Job again, and we select Exelon.cam. Okay, this one is ready to go. It just has this tab. The layers are appropriately selected, drills and holes. And we go ahead and just hit Process Job. Okay, and it automatically created it. If we go back to the Eagle Control Panel, minimize this, go over here, and we'll see that here we have a DRD, which is a drill file, and then this DRI. DRI is the same thing as the GPI file, not necessary. It's only for a summary and for debugging purposes. So you can go ahead and delete this one as well. Okay. So we'll go over here. Now, the only other thing I kind of wanted to detail with you guys about the CAM process, you can see in the other CAM job and in this one, all the tabs are set up the same way. So basically you can put in a section name, the output device, the file name, and then what layers are drawn into that file. Okay, because this is first flights, I'm not going to go further than that, but it gives you an idea of how this works. Okay, so the final thing we want to do, and I encourage all of you to do, okay, always before you send out any of your manufacturing data, always review the Gerbers. It's just a sanity check to make sure everything came out correctly. Okay, so there's lots of Gerber viewers available. You could use something like GerbV, okay, which is for Linux. I personally use ViewMate, which is made by a company called Pentalogics. It's never steered me wrong, so I trust it at this point blindly almost, because I've used it for many years and it's never shown any errors, whereas GerbV has shown errors to me before. But if you're on a Linux or Mac system, GerbV is still your best choice. If you don't mind online Gerber viewers, you can use something like CircuitPeople.com, and that one is also a very reliable Gerber viewer. So to check them, we just go File, Import. I'm going to select Directory. I'm just going to browse to where I have that project saved. So Eagle, First Flight. So you'll see that there's a lot of stuff covered here. And you'll see that everything that's here is okay. These are the files. Everything else, it was able to detect that it's not a Gerber file. So we'll say okay. There we go. So everything looks exactly as I had it in Eagle. So I'm confident in these files, and now I can send them to the manufacturer. Usually you'll just be zipping all of this and then sending it to the board house. Okay? So that's pretty much it as far as generating manufacturing data. If you guys have any questions, please bring them in now through the chat window or through Q&A. I'm going to have them both up. Okay? Any questions, guys? Nope. No. Okay. Cool, guys. So Thank you for participating. Oh, okay. How would you know which job, excellent, etc. to use? Okay. So the way you would know is if you go to the control panel, you can look at the cam jobs. These are the ones that come with Eagle, and you can read the description. So Exelon.cam. This cam job can be used to generate data for drilling machines in Exelon format. Okay? So you know this is the drill data. Okay? If we go to Gerber 274X, it says this cam job consists of 10 sections that generate data for a 4-layer board. Okay? If we go to this one, this cam job consists of 5 sections that generate data for a 2-layer board. So you see that you could figure it out just by going over here. And again, Chapter 9 is another great reference on how to build your own and how these cam jobs work, in very fine detail. Okay, did that answer your question, John? If not, please send me a follow-up question. Okay, any other questions, guys? Differences between vendors. I don't follow, Charles. What specific difference are you asking about? Where we can find the YouTube videos. Okay. Let me go ahead and show you guys to find the YouTube videos. And let me hope that it works. That's the other part, right? There you go. Eagle CAD Soft Computer, and here they are. Okay. So right here, you'll find the videos. Canal von Eagle CAD Soft Computer. So here's a Create Webinar. Here's First Slides Episode 2 and First Slides Episode 1. And they're actually all in a playlist now of Eagle webinars. Okay? So just go to YouTube, user, Eagle CAD Soft Computer, and you'll get us. Okay? Any other questions, guys? Default way of creating Gerbers for all PCB houses 274X. Okay, so Charles, the procedure I went through now for the Gerbers, that works for all board houses, okay? That works for all of them. Those who have worked with Eagle before will recognize the extensions, so they may not ask you what each file represents. However, if you go to a board house that doesn't deal with Eagle very often, they may ask you to specify what each extension means. You know, what does the CMP mean? What does the SOL mean? You can just copy the description from the control panel. If you just copy that'll basically be everything they need. Okay? So if you just copy this little part here, that will basically explain to them everything they need. Okay? Did that answer the question, Charles? Good. Is there anything else, Charles, or any other questions, guys? Okay. If there are no other questions, guys, thank you for your time today. I'll apologize for the interruption we had. If you have any other questions, please feel free to contact us, support@cadsofusa.com. And see you guys next month with the next session of First Flights with Eagle. Next month, we're going to be making a simple component, okay? So we're going to start with an easy component. And then the month after that, we'll probably do a more complicated component. That way you guys get the full spectrum. Okay, so thank you guys. I'll be posting the link shortly after this comes up. And then once it shows up on YouTube, I'll revisit and post that link as well on the page for the webinar. Okay, guys? So thank you very much and have a great day. Bye, everyone.